Okay, good morning class. So today we're looking at calculus, exercise 14. And exercise 14 deals with optimization. Did you make us a marker? Alright. Copy this. So it's calculus, exercise 14, number 1. Okay. Right, so here we are told, unless otherwise stated, give all answers correct to two decimal places, state answers to all calculations involving pi in terms of pi, as well as correct to two decimal places. Okay, so you must give it in both forms, okay? Do not round off your answer until the end. So let's look at the first sum. So here we are told that a right cylinder has a volume of 2 liters. So we know that there's a golden ratio here that says that 1 plug this in. We say 1 million. Okay. We know that 1 milliliter is equal to 1 centimeter cube. Now, if you're looking at 2 liters, how many milliliters is that? 2000, not so. 2000 milliliters equal to 2000 centimeters cubed. Okay. Determine the dimensions. Dimensions is the height and the radius and so on of the cylinder for which the total surface area will be a minimum. The total surface area will be a minimum. Okay, so people, how do you calculate the volume of a right prism? The volume is equal to area of base times height. Why am I going with volume? The reason for that is because if I look at the total surface area, the total surface area is going to be perimeter of base times height plus twice area of base. Remember when we apply the derivative, how do I know I'm going to apply the derivative? They're talking about the minimum. When you're applying the derivative, you want one unknown. And the unknown in this case, you're going to try and make it the radius. Okay? You can make the height as well, but the radius is going to be the bigger of the two. Then we're going to make the height the subject. We're going to write height in terms of the radius. The reason for that is because if you look at the perimeter of the base, what type of shape is this base? Circular base, which is 2 pi r times height plus twice area of base, which is pi r squared. So what I'm going to do is I'm going to write h in terms of pi. That's what I want to do. Okay. So what I'm going to do is, because the volume is given, I'm going to use this formula to get h in terms of, not pi but r. So what did we say? Your volume is 2000. So 2000 is equal to area of the base, which is pi r squared, pi radius squared times height. So how do I get h on its own? Divide both sides by pi r squared. Okay. So h is equal to 2000 over pi r squared. If I substitute this now into the formula that we have here, it's going to be 2 pi radius times 2000 over pi r squared plus 2 pi r squared. Which now gives us, the pi's cancel, the r cancel one of those r's, so it's going to be 4000, 2 times 2000, 4000 over r, which is 4000 r to the minus 1 plus 2 pi r squared. Okay, they determine the dimensions of the cylinder for which, so in other words, we need to still calculate what the radius is and what the height is. So how do I do that? I do that by applying the derivative. So the derivative of the total surface area with respect to R is going to give you negative 4,000 R minus 2 plus 4 pi R. Let's see that equal to 0 and I can drop that. Take it over the equal sign, so it becomes 4,000 over R squared is equal to 4 pi R squared. 4 pi R, sorry. Cross multiply. So that's going to give you 4,000. It's equal to 4 pi R cubed. So I divide it by 4 pi, it gives me 1,000 over pi. So the cube root of that's going to be 1,000 over pi. So we go with the cube root of 1,000 over pi. U6,83. Check if that's correct. So your radius would be 6,83. The radius is 6,83 centimeters. But I have answered the question in full. What do I self-calculate the height? So therefore, no, we'll go of course under here, no? So the height is going to be 2,000 over pi times 6,83 squared. So that gives me 2,000 over pi times answer squared. 13,66. Is that correct? It's 13,66 centimeters. These are dimensions. Okay. The next question says, calculate the minimum surface area of the cylinder. So the minimum surface area of the cylinder will occur at the minimum radius and height. Can you see that, people? So if we're looking at the minimum surface area, so we know the total surface area is denoted as 4,000 R minus 1 plus 2 pi R squared. I can either use that or I can use this formula here. You will see you'll get the same answer. Okay, we should get the same answer. So it's going to be 4,000 into R, which is 6,83 to the minus 1 plus 2 pi times 6,83 exponent 2. Okay, so let's draw that answer there. That's the answer. Okay, so I'm going to say 4,000 times answer to the negative 1 plus 2 pi answer squared. 878,76. Is that correct? 878. 76 centimeters squared. Okay. 1 point. Okay, so that's it. Now we're looking at 2.1. A right cylinder has a surface area of 858 pi centimeters squared. So again we're looking at a right prism cylinder. Okay, so here we've got the radius of course and we've got the height. It has a surface area. So of course now we're going to work with the surface area and I'm sure they're going to ask you with regards to maximum volume. You guys understand? Okay, so the question says determine the dimensions of the cylinder for which the volume will be a maximum. So they give you the one, you must work out the other, or they give you the other and you must work out the first one. Okay, with the one. So let's go. So we know that the total surface area Total surface area is going to be perimeter of base times height plus twice area of base. Okay. Whatever shape is that base? The circular base, which is power squared times height, which is h, plus 2 power squared, which is 2, the area of base is power squared. And this is equal to 858 pi. Okay. So what I'm going to do is I'm going to make h the subject of the formula. Can you see that? So I take 2 pi r squared over, so it's 858 pi minus 2 pi r squared. This is all over, or it's first equal to pi r squared h. Now I divide by pi r squared both sides. And then that's what h is equal to. I'm just going to tidy this up a bit. So h is equal to each one of its own. So I'm going to get 858 pi over pi r squared. So the pi's will cancel, leave you with 858 over r, which is r minus 1, minus 2 pi r squared over pi r squared, which is going to give me an answer. I made a mistake. Where's my mistake? Perimeter. Not so. How do you calculate the perimeter of the circle? 2 pi r. No mistake. Sorry about that. So it's 858. Why didn't you guys even correct me? Pi minus 2 pi r squared over 2 pi r. That's your height. Again, each one of its own. So h is equal to 858 over 2. Gives you 4, 2, 6. How do I get 6? I think that's 16. That is 8. So it's 2, 4. 4, 2, 9. And the pi's will cancel over r, which is r minus 1, minus 2 pi r squared over 2 pi r is going to give you r. So that is your height in terms of r. So what did they ask us? They asked us with regards to the volume. So volume is going to be area of base times height. So what's the area of this base, circular base? Pi r squared, and my height is nothing. So it will be pi r squared into 429 r minus 1 minus r, which is 429 pi radius squared times r to the minus 1 is r minus pi r cubed. The question is the volume will be a minimum. So now I apply the derivative of the volume with respect to r. So dv over dr is equal to, apply my derivative, is 429 pi minus 3 pi r squared. Okay, and I say this equal to 0. So my aim is to get r squared on its own. So r negative 3r squared is equal to negative 429 pi. So I divide both sides by negative 3 pi r squared. No, 3 pi r. That way, that cancels. So 429 over 3. You 143. So r is equal to 143, the square root thereof. It's plus minus 143. But can radius be negative? No. So it's going to be the square root of 143, where r is, of course, greater than 0. Is that correct? Okay. So what do we do from here? We work out our height. So of course, that will of course goes at the bottom. So height is equal to 429 times the square root of 143 minus 1 minus the square root of 143. Okay. That gives us 429. 429. Answer to the negative 1. Minus the answer. 23,9. Is that correct? 3,9. 23,9. 92 centimeters. Right, you guys understand? Let's go to the next question. Calculate the maximum volume of the cylinder. So the maximum volume of the cylinder will occur at the maximum radius. Not so. Or the maximum radius and height. So if I use this formula here, I'm going to substitute R to be a root of 143 and a height of 23,92. Otherwise, if I use this formula here, this one here, remember that is also the volume. So the volume is equal to 429 pi with the radius of 143 minus pi times radius of root 143 cubed. Okay, so let's just get that 143 here. Square that out. Alright, so this is going to be 429 pi answer minus pi answer cubed gives us 10,744,44. Is that correct? Okay, 10,744,44 centimeters. Okay. Is there any confusion there? No? Yes? No question? Okay. Let's look at number 3. I'm not even changing these numbers here, you guys. Why didn't you tell me? The box below is a right prism with a volume of 5,000 centimeters cubed. So what do you think they're going to ask? Surface area. Yes, surface area. As I said, if the volume is given, the surface area will be asked. If the surface area is given, the volume will be asked. Okay. So how do we calculate the volume of a prism? Volume is equal to area of base times height. Alright. The length is 4 times the breadth. The length is 4 times the breadth. The breadth is x and you got the height. Determine the total surface area. So what are we going to work out here, people? We're going to work out the height in terms of x. So what's the volume? 5,000 is equal to area of this base. How do you calculate the area of a rectangle? Area of a rectangle? Let's put this off here. Area of a rectangle is length times breadth. Okay, and times the height. So what's the length here? My length is 4x, my breadth is x, and my height is h. And that's equal to 5,000. How do I get h on its own? Divide by 4x squared, both sides. So h is equal to, what's 5,000 divided by 4? 5,000 divided by 4. 1250. 1250 over x squared, not so. Bring that up, becomes x to the minus 2. Why do I bring that up all the time? Is because it makes it ready to be, and then the derivative to be taken off. Okay? On the other hand, the question says determine the total surface area of the box in terms of x. So the total surface area is going to be perimeter of base times height plus 2 or twice area of base. So how do you calculate the perimeter of a rectangle? It's going to be 2 length plus 2 breadth times height. And this is height is going to be replaced with this here. Okay? Plus twice area of a base, so it's 2 length times breadth. This is the substitution, is simply going to give you 2 length, which is 4x, plus 2 breadth, which is x, times height, which is 1250 x minus 2, plus 2, my length is 4x and my breadth is x. So what is 2 times 4x? 8x. 8x times 2x? 8x plus 2 times x. So 2 times x is 2x. 8x plus 2x is 10x. Now 10x multiplied by 1250, x to the minus 2 is 12500. X to the negative 1 plus 2 times 4 is 8 and x times x is x squared. So there is the total surface area in terms of x. Is that correct? Check it? Yeah. Right. Sorry? Sorry? What?
It's correct.
Oh, it's correct. Somebody did it tell us. Yeah. Well, the next question says, determine the dimensions of the box to which the total surface area will be a minimum. So what must I do? I must take the derivative of the total surface area. So the derivative of the total surface area with respect to x equals, now apply my derivative. So it's negative 12,500 x minus 2 plus 2 times 86 to x. Set that equal to 0. Take that over the equal sign. So 16x is equal to 12,500 over x squared. So what do I do now? Cross multiply. So 16x times x squared is 16x cubed is equal to 12500. So x cubed is equal to 12500 over 16. Gives us that answer. The cube root thereof gives you 9,21. Is that correct? 9,21. I think it was centimeters, no? So it's centimeters. If it was meters, and it would be, of course, meter. Yeah, centimeters cubed, so it's in centimeters. Then it says calculate the minimum surface area. The minimum surface area will occur at the minimum value of x here. Not so. So to work out the minimum surface area, I just substitute wherever I see an x, I substituted with 9,21. So the total surface area is going to be 12,500 times 9,21 to the negative 1 plus 8 times 9,21 squared. Alright, so it's going to be 12,500 answer to the negative 1 plus 8 times answer squared. Is that correct? 23.5, the 2035, comma 8 to 1. Sorry? So yeah, I only found the okay. So I'll do that now. Is this correct? Centimeters squared. Thank you. The question here was length, breadth and height, of course. The breadth was x, so the breadth is going to be 9,21. The length is 4 times 9,21. 4 times 9.21. It's going to give you 36,84. 36,84. And of course the height is going to be 1250 times 9,21 to the negative 1. So it's 1250 negative 2 times 9.21 to the exponent. Is that correct? 14,74 centimeters. Thank you once again. Let's look at number 4. So here we are told that the storage container in the form of a right prism has a total surface area of 32 meters squared. So again, we have something similar to the one above. And now the total surface area is given. So what do you think they're going to ask us in regard to the maximum volume? So how do we calculate the total surface area? It will be perimeter of base times height plus twice area of base. Okay. The total surface area is going to be 34 meters squared. If the length is 5 times the breadth, so if you make the breadth x, the length will be 5x. And of course you got the height here. It says then, determine the volume of the container in terms of x if the breadth is x meters. Okay. So how do you calculate the perimeter of this base? That is of course your base now. How do you calculate the area of a rectangle? So it will be 2 length plus 2 breadth times height plus twice area of base, which is length times breadth. Now of course your total surface area is 34 is equal to 2, your length is 5x and your breadth is x, is 2 times x. Your height is h of course plus twice area of base is going to be length times breadth. Okay. And your length here is 5x and your breadth is x. So 2 times 5x is 10x plus 2x is 12x. Not so? So it's 12xh plus, that's going to give us 10x squared, and this is 34. Bring that over the equal sign, I want to make h the subject of the formula. So 34 minus 10x squared equals 12xh. Divide by 12xh both sides, 12x both sides. So h is of course equal to 34 over 12. I'm going to leave it this. Okay, 2 goes into 34 17 times. Is that correct? 17 over 6. I'm putting each one of its own now. X to the minus 1. And negative 10x squared over 12x is negative 5 over 6x. Okay? What's the question? The question says determine the volume. So how do you calculate the volume? Volume is equal to area of base times height. Where do I get this from? Grade 8 and 9 formulas, no? For those of you who thought you're never ever going to use that again. So the area of the space is going to be length times breadth times height. My length of course is x or 5x. My breadth is x and my height is of course 17 over 6. X minus 1 minus 5 over 6. Five over 6. Oh, is it minus 1? Minus 1 minus 5 over 6x. Okay, so this of course will be 5x squared. No? Multiply that in. So 5 times 35 is 65. Let's check there. 65 over 6x minus, that's 25 over 6x cubed. Just check if that's correct. Huh? Sorry? 85. 5 times 17 is 85. Oh, it's 13, sorry. 13 times 5 is 65. Sorry. Now, I'm going to use this weekend now to redeem this 85. Should be 85. Is that now correct? Yes. I'll do extra maths over the weekend. Then the question in 4.2 says, determine the dimensions of the container. That's the breadth and height. Determine the dimensions of the container for which the volume will be a maximum. So what must I do? Plot the derivative. So the derivative of the volume with respect to x is equal to, plot my derivative here, I then get 85 over 6 minus 25 over 2x squared. 25 over 6 times 3 should be 25 over 2. I say this equal to 0. Drop that. So what I have now is going to get over the equal sign, so it's going to be 25 over 2x squared is equal to 85 over 6. So x squared is equal to, then I'm going to do that in my head. So it will be 85 over 6 divided by 25 over 2. So we give us 17 over 5. 15, the square root thereof. And they give you plus minus 1,06. But x has to be positive because I've been talking about length here. So x is equal to 1,06 centimeters as x needs to be greater than 0. Is that correct? Right, so the question was for the dimensions, of course. So you got length, breadth and height. So the breadth, of course, is 1,06. The length is 5 times this. 5 times 1,06. And multiply that by 5, I'm going to get 5,3. Is that correct? Okay, and the height is going to be 17. Of course, the height is going to be 17 over 6 times 1,06 to the minus 1 minus 5 over 6 times 1,06. Okay, so that is 17 over 6. Answer to the negative 1. Okay, get this use here. Minus 5 over 6 answer. Give me an answer of 1,77. Is that correct? 1,77 centimeters. Okay, it looks a bit flat here. Move this over. Okay. Okay. Any confusion here? No? Of course, if you didn't do the homework, then you won't have any confusion. The question says determine the maximum volume of the container. The maximum volume will occur at the value for x for which the maximum occur. So what we'll do is wherever we see a x, we put a 1,06. So the volume is equal to 85 over 6 into 1,06 minus 25 over 6 into 1,06 answer cube or cube. So I got 85, I'm just going to say 1,06. Okay, so it's going to be 85 over 6. Answer minus 25 over 6. Answer cube. Give me an answer of 10,05. Is that correct? Huh? Yes. No, yes. Yes, yes, yes. Okay. That is centimeters, no? Centimeters. Alright. Any confusion there? It's on page 181. How many sums do you have left? We have 10 sums. So I'll do number 5 in our extra lesson this afternoon, so I can load up this video today. Okay. You will enjoy the rest of your day. Morning class. Okay, good morning class. So today we're looking at calculus, the optimization, exercise 14. At this point we have finished the first 4 questions, correct? So now we're going to look at question 5 and then we're going to do the rest of the questions in the next video. Okay, so this will be merged with questions 1 to 4. Okay, what's wrong? The mark wrong. Add up wrong. Do you have any questions for the cycle test you guys have written? We're going to do the memo tomorrow. Inshallah, and then we will take it from there. Okay. Okay. So in number 5, you are told that the ball is thrown into the air and its height is given by h of t equals negative 5t squared plus 59 over 2t plus 3. Where t is the time in seconds and h is the height in meters. Determine the height of the ball above the ground after 2 seconds. Okay, so as you can see here, this actually models a parabola. Not so. And it's a maximum parabola. How do we know that? Because, right, it's negative. Okay. So just bear that in mind. Determine the height of the ball above the ground after 2 seconds. So the height after 2 seconds is simply negative 5 times 2 squared plus 59 over 2 times 2 plus 3. So it's going to give you 59 minus 20 is 39 is 42. Let's check if that's correct. Just put up the calculator as well. So it's negative 5 times 2 squared plus 59 times 2 divided by 2 plus 3. 42 meters. Okay. Question 5.2, we are told to determine the average speed of the ball during the first 2 seconds. The average speed of the ball during the first 2 seconds. So as we would have worked out our average gradient, we work out our average speed as well. Okay. So what we have here is our average speed. Is going to be the displacement or the height after 2 seconds minus the height to 0 over 2 minus 0. Okay? If it was determine the average speed of the ball during the first and the second second, you know, the worked out the displacement of 2 seconds minus the displacement after 1 second. Then it will be 2 minus 1. The average speed of the ball during the 5th and 6th second is simply going to be the displacement after 6 seconds minus the displacement after 5 over 6 minus 5. Determine the average speed of the ball during the first 5 seconds. It will be h of 5 minus h of 0 over 5 minus 0. Alright. So that's simply going to be h of 2. So if I put 2 into this calculation, I'm going to get 42 minus h of 2 is going to give you 3 over 2 minus 0. So it's going to give you 39 over 2. Not so. 39 over 2. Or 1 and 19 comma Okay, meters per second. Okay, is that correct? Does that mean that we know going off? Sorry? 14. So it's 42 minus 3 over 2. 19.5. You see where am I going wrong here? It says 42. I think they are wrong. Just make that correction in the textbook. They say it's 14.5. Yeah, that is not correct. Okay, it must be 19.5. Where am I? Did any of you get 14.5? Huh? So it's 19.5. The next question says in 5.3, what is the velocity of the ball after 2 seconds? But what do we say? What is velocity? Your first derivative, not so. So the velocity is the first derivative. So it's the derivative of displacement, which is h dash t is going to give you negative 10t plus 59. So the speed, velocity is basically speed, after 2 seconds. So h prime of 2 equals negative 10 times 2 plus 59. So that's going to give you negative 20. So it's 29. 39, sorry. Meters per second. Is that correct? Alright. The next question, we are told what is the acceleration of the ball after 2 seconds. So what did we say? What is acceleration? Second derivative. So we're going to work out the acceleration, the second derivative. So it's h double dash of t equals negative 10 meters per second squared. Okay. So if you look at, you're applying a derivative here. The derivative of constants again, 0 there. So that means to say at any given time, the acceleration is going to be negative 10 meters per second squared. So if you're looking at after 2 seconds, it will be negative 10 meters per second squared. Okay. Yes? Sorry? 9.5. H prime of t 29.5. Okay, so if you go back up here and you apply the derivative to this function here. Okay, so that's going to give you negative 10t plus 59 over 2. Okay, that's my mistake. Yes. Let's go here again. I apply the derivative, but why did I say multiply by 2? Okay, this is my mistake here. So that is going to simply be negative 10 times 2 plus 59 over 2. 9.5, that's absolutely correct. 9.5 meters per second. Thank you. And then of course the 5.4 correct? Right, let's look at 5.5. The question says, at what time did the ball reach a maximum height? So the maximum height, that's your first derivative, and you set it equal to 0. So h prime of t is equal to negative 10t plus 59 over 2. Is that correct? No? And we set that equal to 0. We take it over the equal sign. So 10t is equal to 59 over 2. We divide by 10 both sides, and we're going to get 59 over 20. Or in decimal. It will be 59 over 2 divided by 10, 59 over 20, or 2,93 seconds. Okay? 2,95 seconds. Okay? 2,95 seconds. Question 5.6. When did the ball hit the ground? So the displacement there is going to be 0. Okay? And I don't think I've answered this question completely yet. At what time did the ball reach the maximum height? And what was the maximum height? So the second part of the question we didn't answer. The maximum height will occur at the maximum time taken to reach that height. So it's the height of 2,95. So my formula is negative 5t squared. So it will be negative 5 2,95 squared plus 59 over 2. So it's plus 59 over 2 times 2,95. And then plus 10. 3 plus 3. Okay, so it's going to be negative 5 answer squared plus 59 over 2 answer plus 3. That gives me a height of 46,51. Is that correct? So it's 46,51 meters. Okay. The next question, when did the ball hit the ground? The ball hit the ground when your height is equal to 0. Alright. So if the height of the displacement is equal to 0, so it's going to be negative 5 t squared plus 59 over 2t plus 3 is equal to 0. Now you can apply the quadratic formula, or you can complete the square, or however else you would like to do it. So what I'm going to do is I'm just going to use the calculator. Alright, so mode. So it's going to be negative 5. Then is 59 over 2. And 3. The first answer is 6. After 6 seconds, or after negative 0.1 second. Can it be negative 0.1 second? No. Of course not. So therefore, after 6 seconds. Okay. After 6 seconds, it will hit the ground again. Okay. Is that correct? Let's look at 5.7. At what speed of the ball, what was the speed of the ball at the moment that it hit the ground? So speed is again first derivative. Not so. So we work out our first derivative. So 5.7. Our first derivative, we worked that out already. So h prime of t was negative 10t plus 59 over 2. So it's going to be negative 10 multiplied by 6 plus 59 over 2. So put that in the calculator. It says negative 6. Negative 6 times, no, negative 10 multiplied by 6 squared plus 59 over 2. So it's negative 300 and not squared. I was thinking of that's fairly large. Negative 30.5. Negative 30.5 meters per second. Or you can say it's in the downward direction of 30,5 meters per second. You guys understand? Right. Well, the textbook give you an answer? They use a negative. Okay. Normally they would interpret this, but I see they just give you the answer as it is now. Okay. So that brings us to the end of this video here.